This question came in from an online student, and it's an excellent question to look at for multiple reasons. No pun intended. Now, if you don't get the humor there of what the pun is, you'll have to watch this video a second time around to see if you catch what multiple has to do with this example. But this example is an example of multiplying rational expressions. There's an implied requirement when we multiply rational expressions that we've got to then reduce or simplify. So let's look at this example. We've got x squared minus 81 over x squared minus 2x minus 63. And we want to multiply that times x plus 7 over x. Now, it's a little bit of a hidden question here because we're not really so much as multiplying as we are factoring and then reducing. So when you see an example like this, even though it says to multiply by saying find the product, what you want to think about is I want to factor and then I want to reduce. Here's what that would look like. To start with, if we factored, we'd want to first notice that this x squared minus 81 is what we call a difference of squares. It follows the pattern a squared minus b squared. It's an x squared minus 9 squared. X squared minus 9 squared, because 81 is a perfect square. X is a perfect square. And we've got the difference of those two perfect squares. So that's what makes it a difference of squares. This is a really important pattern to know by memory because it's actually the only way to factor this binomial is to know the pattern. X squared minus y squared would equal x plus y times x minus y. Or a squared minus b squared will equal a plus b times a minus b, or in this case, x squared minus 9 squared. So the first step was to recognize that this is a difference of two squares. How do you do that? Well, if there's two pieces, it's a binomial and it's a difference. All you have to do is think through whether the first and last term are both perfect squares. And if they are, then it's going to factor like this. X plus the square root of 81, which was 9, times x minus the square root of 81. So we have x plus 9 over x minus, or times x minus 9. Let's now move to the denominator, the x squared minus 2x minus 63. To factor this one, I'm going to use this factoring diamond, or whatever you'd want to call this pattern. If you haven't seen this yet, and you weren't able to factor this x squared minus 2x minus 63 easily, then I'd want to encourage you to try this factoring diamond. What I've done here is I've taken this negative 63 and I put that in the top of the diamond. So what I'm looking for is two numbers that when I multiply, I get a negative 63. And then I took the negative 2, the coefficient of the x, and I put that in the bottom of the diamond. So what I'm trying to do now is find two numbers that multiply this negative 63 and that add to negative 2. To do that, I'm going to make a short list of all the whole numbers that can multiply to 63. Notice I've changed it to positive 63. I'm not going to be concerned about the negative yet. Starting with a 1, I could do 1 times 63. It's not even, so 2 doesn't go in. If I pulled out a calculator and did 63 divided by 3, I'd get 21. 4 is not going to go in. 5 isn't. 6 isn't. If you could try a 6, 63 divided by 6, you see it doesn't go in evenly. 7 is the next number that goes in evenly to 63. So even if you're not really familiar with your multiplication facts, you could use a calculator to do 63 divided by 2, divided by 3, divided by 4, divided by 5. It would only take a few seconds to get this. The divided by 7 works out. And then we could try 8. 8 wouldn't work. And when you get to 9, you'd get a 7, but notice that now you're repeating. And that's how you know you're done. So there's only those 3 pairs of factors for 63. So if this does factor, then it's going to be one of these 3 pairs. And so now I'm looking for which one could add or subtract to a 2, and you guessed it, it's the 7 and the 9, right? Now I'm just going to decide which one's positive, which one's negative, because I want a negative product, so I know that one of the two is negative. If I want a negative sum, then I need the bigger of the two numbers, the 9, to be the negative. So it looks like the answer here to this number puzzle is 7 and negative 9. So when I go to factor this, what I would get is x plus 7 and x minus 9. You can try that. You can check it by multiplying. So if I check that multiplication, x times x is x squared, outside times outside is negative 9x, inside times inside is 7x, outside times outside is 63, and these two simplify to a negative 2x. So we get x squared minus 2x minus 63, which is what we started with. So I do in fact have the right factors, x plus 7 and x minus 9. So now when I go back to my problem, this x squared minus 81, I've factored it to x minus 9, x plus 9, the x squared minus 2x minus 63, the denominator is x minus 9, x plus 7, and I'm done factoring. Now, all I have to do is go through to reduce. To reduce, I'm going to look for anything in the numerator that has a match anywhere in the denominator. Notice that the x minus 9 has a match, an x minus 9, and the x plus 7 has a match, the x plus 7. I'm not going to say cancel here, and let me explain why. I'm going to say that these reduce because this x plus 7 over x plus 7 divides out to 1. We're looking for things that divide out to 1. This x minus 9 over x minus 9 is just a fancy way of saying 1. And then what am I left with? I'm left with x plus 9 over x. Now this is the final answer, but let me warn you about a common mistake, this very last part. Some students have a desire to take this x over x and reduce it. Say that x over x equals 1. Well, yes, x over x does equal 1, but this isn't an x over x. What we have to recognize instead is that it's an x plus 9 over x. And that x plus 9, even though there aren't parentheses written on it, when I see x plus 9 over x, you have to notice that it's got an implied parenthesis because it's in the numerator. It's separate from the denominator. It's like an implied grouping symbol when we have this fraction bar. So this x over x can't reduce because it's not part of a factor. Or it's not part of a product, I'm sorry. It's not a factor. Now if I had x plus 9 over x, now I could reduce, but I can't reduce these x's. So the final answer is x plus 9 over x. Well, I hope that this tutorial has helped you with having a better understanding of this type of problem. If you're in one of the online classes, I want to encourage you to let me know if you have further questions about this, because online doesn't mean on your own. I am here to help you on your pathway to success.